All right, so we are going to go over the geometry review for our Unit 5 test. Oopsie, didn't mean to draw that. So first one, 3 postulates or theorems that prove that two triangles are similar. You have AA similarity, SAS similarity, and SSS similarity. And remember, you have to include the little similarity symbol, that little squiggle at the end. Otherwise, it does not actually mean the same thing. So for 2 and 3, we need to figure out if the figures are similar. So remember, in order for things to be similar, they have to have all their sides proportional and all of their angles the same. So if we notice, we are told that these are rectangles, so that we know all of these angles are right angles, so that we know all of those are good to go. So then to set up the proportion, you'd have 4 over 6 equals 12 over 16. And really, if you just wanted to simplify those fractions, you could, because that would be 2/3 equals, and then you divide both of these by 4, and that is 3 over 4. So notice those are not the same number, so they are not equal. So these are not similar. And they're not similar because sides are not proportional. Sad day. So for the next one, we need to, same thing, prove they're similar or not. So looking at the angles, they both have 2 right angles, and then we have angle U and angle L are the same, and angle M and angle V are the same. So we know that these are going to be, all angles are congruent, so we're good there. So then we just need to check the proportion of the sides. And you want to be careful, because like KL, that goes from a 90 to a single, so that means it's going to correspond to UT. JM is going to correspond to VS. And then, oops, let's do orange. JK is going to correspond to TS. And let's do dark blue. ML is going to correspond to UV. So if it helps you to use colors to kind of figure out what your corresponding pieces are, that's totally fine. Just notice that I basically use my angle measures to help me. So since this angle U only has one little spot, and then so does the angle L to the double with M, then it's going to be with the UV. So to actually do this, we'll compare. We have 20 over 24, which would simplify to, if we divide by 4, 5 over 6. If we do 10 over 12, same thing, we get 5 over 6. If we do 30 over 36, that's the dark blue, again, we get 5 over 6. And then the light blue, 14 over 16.8. I don't know what that is off the top of my head, but looking, 14 divided by 16.8 is 0.833 repeating, and 5 divided by 6 is also 0.83 repeating, so I know that this is also going to be 5/6. So since all of these are the same, all sides are proportional, these are similar. Our similarity statement is just saying that one one of these shapes is similar to the other, so you just use the letters, but remember they have to be corresponding. So I will start with JKLM is similar. Now J is my light blue and orange, so that means I'm going to have S first. K is the green orange, so it's going to be a T. L is dark blue and green, so we have U and V. So JKLM is similar to STUV, and our similarity ratio is just the numbers 5 over 6. Okay, you don't have to put like JK over STS equals this over that. You can just give me the number for the similarity ratio. So for 4 and 5, you have to list the postulate or theorem that proves that the triangles are similar and write a similarity statement. So looking at this, we are only given one side measurement, which, remember, we have AA, SAS, and SSS. Since I only have one side length, I know I can't use SAS or SSS, but they do tell me that C and E are congruent to each other. And then you also have this reflexive angle A at the top. So this would be an angle-angle similarity, and you would have triangle AED is similar to triangle ACB. And again, I used the angles that I knew were congruent to help me set up my similarity statement. And just one thing to consider, because I've had a lot of people that say SAS or SSS when they're only given one side length, really try to do AA first, because it's a whole lot easier to prove that two angles are similar or congruent than it is to prove that sides are similar. So for this one, you actually have two potential answers. But since these are isosceles triangles, I know that these two angles are going to be congruent. So if I do 180 minus 40, that means I have 140. So each of these are 70 degrees, which means all of these are also 70 degrees. So this one could be AA similarity. It could also be SAS similarity, because we have these little marks right here that tell us that it can be. So either one is fine, because 10 to 5, that's half as much, and 6 to 3 is also half as much. So SAS would also work. And technically, you could also prove SSS with this one, kind of depending on how you looked at it, because if you knew that that was 10, then you could prove that all the sides are proportional as well. So that's one where any of them will work. You just have to know how to prove each one. So since we can prove it all of the ways, we would have triangle ABC is similar to triangle PQR, just like that. Okay, so just make sure when you're given triangles, you know which one is going to work the best for you. And if it is more than one, just pick one. It doesn't really matter, as long as you can actually prove it all the way. So, let's continue on. Forgot to X out of my emails, I'm sorry. So this one is a proof, and we are given that MN is parallel to KL, and we need to prove that JMN, that's this little one, is congruent to triangle JKL, which is the big one. So looking at those triangles, I may have made it worse that way. Looking at the triangles, because these lines are parallel, that kind of is a big giveaway. But of course, we need to write it first. MN is parallel to KL, and that is given. Boop. Actually, I'm not going to click that. So, then because these are parallel, I know that angle L is going to be congruent to angle N, well, JNM, because of corresponding angles. So I'm going to have angle JNM is congruent. And this is one of those times that you could, for angle L, you could just name it angle L, or you can actually put all the numbers or all the letters. So JLK. Personally, if I start with 3, I like to end with 3 too. But I don't think it actually matters if you were to just put angle L. But that is corresponding angles. And then we do the same thing, except we have angle JMN is congruent to angle JKL. And again, corresponding angles. Now, technically, there is a third angle that you can prove. So for the sake of just you guys being aware, we would have angle J is congruent to angle J because of the reflexive property of congruence, because they are congruent. I will say that you do not need to include this step unless you haven't used the other, because you already have your two angles proven that they are congruent, so you don't really have to worry about it. But I mean, for some people, it's not a bad idea just to have the extra. So we have triangle JMN is similar to triangle JKL because of angle-angle similarity. Okay. So our next one, we got some more magical parallel lines. So that'll be our given. Oops. So we have QR is parallel to ST. So then because these are parallel, that should be a little hint in your brain that they're either going to be corresponding angles or there's going to be alternate interior. And looking at this, because I see this little z in here, even though it may be sideways, it's still a z, that tells you that there's going to be alternate interior angles. So you have angle R and angle S that will work. So angle R is congruent to angle S because of alternate interior angles. And then you also have angle Q is congruent to angle T because of the same reason, alternate interior. And something you have to be careful of when you have these Z shapes is that it is opposite. So it really is Q and T are corresponding. So if you have to set up something with the sides, then this QP corresponds to that PT. And just something to consider if you have to find unknowns. So we have two angles proven, so technically we don't have to do anything else. We can just say they're similar. But again, just so that you can see the other one that you could have proven, you could have said also angle RPQ is congruent to angle SPT. And notice R and S, because those are my opposites, those are going to be the corresponding pieces. And that is because of vertical angles. Again, you don't have to include that orange bit because you've already proven that two angles are congruent, but it's never a bad idea just to include it anyways. So we have triangle PQR is similar to triangle PTS because, again, a similarity. So our next one, finding a value of x, they already tell us that these shapes are similar, so that kind of takes some of the work away from you. So then you just, since they're similar, set up a proportion. Some people would want, I've seen, they set it up as 4 equals x plus 3. But that doesn't work because that would be saying that the shapes are congruent, not similar. So since these are similar, you set up 4 over 3 equals x plus 3 over 2x minus 4. Okay, and I'm going to erase the wrong way of doing it because that's no bueno. But if you notice, 2x minus 4 corresponds to 3, and x minus 3 corresponds to 4. So then when we cross multiply, let me change my color, you would have 4 times 2x minus 4 equals 3 times x plus 3. Again, when you set up proportions, make sure you put those two things equal to each other because it does make a difference. So 4 times 2x is 8x. 4 times negative 4 is negative 16. 3 times x is 3x, and 3 times 3 is 9. So then to finish solving this, we'd subtract 3x. And we get 5x minus 16 equals 9. When we add 16, you would get 5x equals 25. And then you divide by 5 to get x equals 5. And you have to be careful with these sometimes because the question will tell you what they want. If they just want a value for x, you just have to say x equals 5. If they wanted the length of EF and FG, then you'd have to plug in that 5 into these numbers. So you'd have like 5 plus 3 equals 8, and then that side would be 8. But this one just wanted x, so we don't have to worry about that step. So this one, again, is just worried about x. So we already know these triangles are similar, so we don't have to do anything fancy with that. So then looking at this shape, because they're oriented differently, it is easier for me to kind of see which ones are similar if I just orient them the same way. So I'm just going to flip this ZYX upside down. That way I can see it a little bit easier. Okay. The other thing that will help you is if you look at what their similarity statement, that kind of tells you what corresponds. So MP, which is x plus 5, corresponds to XY, which is, wait a second. Never mind, their similarity statement's not very good. So that's going to correspond to the 30. Duly noted that we need to fix that one. But it's going to correspond to the 30, and then you have 4x minus 10 over 75. So then when you cross multiply, you'd have 30 times 4x minus 10 equals 75 times x plus 5. So when you distribute, you'd get 120x minus 300 equals 75x plus 75 times 5 is 375. Oops, 375. And so when you move them around, I would subtract the 75x first. And for the sake of space, I'm not going to write every single step. But that would give us 45x. And if you add 300 at the same time, you get 675. So again, I subtracted 75x and I added 300. So then when I divide 675 divided by 45, that gives me x equals 15. Again, they are wanting a value of x, so I don't have to do anything special with it. I just get x equals 15, and I'm done. So, next one, we have to find PS. And so you have to be careful because they already said that x is QS. So when you have to find PS, you're going to have to actually add them. So looking at these triangles, even though they don't require you to tell them why they're similar, we know they are similar because of AA similarity. Angle P is congruent to itself, so we don't have to worry about it. So when you set up your proportion, you'd have 5 over 6 equals, remember PS is the entire long side, and it's 5 and x, so you'd have 5 plus x over, and then your long side is just x plus 7, and they just give that to you. So when we cross multiply, we have 6 times 5 plus x equals 5 times x plus 7. Then when we distribute, boop, boop, you get 30 plus 6x equals 5x plus 35. So when you subtract the 5x, you get 30 plus x equals 35. And then you'd subtract the 30 to get x equals 5. And then if x equals 5, you're just plugging that in. So to find the length of PS, you'd have 5 plus 5, which is 10. Okay, so just make sure you're really careful with those because I've seen a lot of times people mess up right in here. Make sure that whenever you're setting up your proportion, it's the full side of the triangle, not just a partial side. And that just kind of depends on the problem. So you'll just have to be aware of that. So our next one, we have to find PQ. So I will just put an X in there. Oops, I was still on the highlighter. Since I'm finding PQ, the nice thing is when I solve for X, it's going to be PQ. So when you set up the proportion, again, we have this reflexive angle in here. And then because of those parallel lines, you have corresponding angles. So we know that this is similar again because of AA similarity. But then when you set up your proportion, remember it's this little triangle to the big triangle. Okay? I know that made it kind of ugly, I'm sorry. But make sure that you understand what triangles they are actually talking about. So looking at little to big, we could have 15 over x equals the long side of the big triangle would be 15 plus 6, which is 21. And then the side with the x on the long one would be x plus 5. So again, be careful. Make sure it actually represents the entire side. So when we cross multiply, we get 21x equals 15 times x plus 5. Then when we distribute the 15, we get 15x plus 15 times 5 is 75. So then we want to subtract the 15x to get the x's by itself. So we'd have 6x equals 75. And 75 divided by 6, you get x equals 12.5. So then because, again, I made PQ be represented by x, I know that PQ is 12.5. And we don't have units, so we'll just leave it as 12.5. Okay? So our next one is we need to verify that AB is parallel to CD. And so remember, in 7.4 we had triangle proportionality theorem, converse triangle proportionality theorem, and triangle angle bisector theorem. So in order to verify that these are parallel, that would be the converse triangle proportionality theorem. And what that says is that these sides need to be proportional to each other. So just make sure that you're careful. This full side is 10, and this full side is 7.5. You don't want to just compare 4.5 to 3 because that's just a small portion of the big side. So we have 4.5 over 6 equals 7.5 over 10. When we cross multiply, we'd have 45 equals 6 times 7.5 is 45. So since these are equal to each other, we know that they are proportional. And so because it says show work for points, it's really, can you set up the proportion like I did here, and then can you prove that they are proportional? If you set up individual fractions and then compared the ratios, that would also be fine. But we do know that now that AB is parallel to CD because of the converse triangle proportionality theorem. For 13, we have to find the length of CE. So I'm just going to label that as X. And so because these are parallel, again, we have corresponding angles right here. So that's kind of the nice thing. We know that this is similar because of AA similarity. So then you're having to set up the proportion. So remember, you need the full side, so you'd have 8 plus 12 is 20, and then 15 plus x, because we don't know what x actually is. So when you set up your proportion, you can have 12 over 15 equals 20 over 15 plus x. I find that if I have sides where I have to combine them, like 20 and 15 plus x, I do better if I set up the proportion little to big. So all of my littles to all of my bigs right over here. So when we cross multiply, 20 times 15 is 300. And then we have 12 times 15 plus x. So we'd have 300 equals 180 plus x. So when you subtract 180 from 300, you get that x equals 120. Oh no, what in the world did I just do? Silly me. If you didn't notice, it should be 12x. Oopsie. Be careful. I do that sometimes. It's 12x. We have to distribute it. So that'd be 12x equals 120. I thought that number seemed really big. And then when you divide by 12, you get that x equals 10. So if you ever get in a situation like I just did where I forgot to distribute and then I was getting that my final answer was 120 for x, you can see that it's clearly not going to be 120 because of how long that side is. So we do know that x equals 10. So then we'll go ahead and set it up. X equals 10. X represents CE, so my answer is 10. And that's all you have to do for that one. So just make sure when you distribute to everything. I have a bad habit of not doing that sometimes. So our next one, if you can't tell what theorem you're using right off the picture, you should probably look at the pictures more, because this is the triangle angle bisector theorem. Again, I see a triangle. I see an angle that is bisected, so it's triangle angle bisector theorem. So with this theorem, you just have to set up a proportion. So 8 over 12 equals y plus 1 over 2y. So when I cross multiply, I'd have 16y equals 12 times y plus 1. And this time I'm going to doubly make sure that I actually distribute all the way. There we go. So when I subtract 12y, I get 4y equals 12. And then divide by 4, and y equals 3. So then if y equals 3, SU is y plus 1. So 3 plus 1 is 4. And SV is 2 times 3. So that would be 6. Okay, so just make sure you're aware when they need something else, give them something else. Plug it in if you have to. Okay. Next one. Again, I see a triangle. I see an angle that's been bisected. So it's triangle angle bisector theorem. And that was in 7.4. So if you don't remember it, just go back, look at 7.4. But you set up a proportion. So we'll set it up x plus 5 over x minus 5 equals 12.5 over 7.5. And this problem you've actually seen a couple times. So by now you may just remember how to do it. But you still going to cross multiply. So 7.5 times x plus 5 equals 12.5 times x minus 5. Then when you distribute everything, you get 7.5x plus 37.5 equals 12.5x minus 62.5. So if you subtract 7.5x, you get 37.5 equals 5x minus 62.5. And then for the sake of space, when you add 62.5, you get 100. So then x equals 20. And then because they want SR and ST, you plug it in. So SR is 20 plus 5, which is 25. And ST is 20 minus 5, which is 15. Oops. Okay. All right, sorry for all the coffee. So we need to use the dimensions in the diagram to find the height h of the tower, and we need to give our answer in terms of feet. Oopsie. So we're going to round our answer to the nearest hundredth. So even though they want it in nearest foot, I'm going to convert all of these to inches. That way I don't have any repeating decimals, because that generally makes things a little bit more complicated. So if it's 11 feet long, that is 132 inches. So plus that 3 inches is 135 inches. 5'5", 5 is 60 inches, so that means he's 65 inches tall. And then 1'3", obviously 1 foot is 12 inches, so his shadow is 15 inches long. So to set up the proportion, you can have h over 65 equals 135 over 15. So that would give us 15h, equals, we have 65 times 135, which is 8,775. And when you divide by 15, you get that the height of the building is 585 inches. Remember, you did convert it to inches. So when you divide by 12, you get 48.75 feet. And since they wanted the nearest hundredth, you don't even have to put any inches. It's just 48.75 feet. Now, if it does not specify to the nearest hundredth, then write it as feet in inches. So that would be 48 feet, 9 inches. So a student wanted to find the height of a statue of a pineapple in Nambour, Australia. She measured the pineapple's shadow to be 8 foot 9 inches and her own shadow to be 2 feet. The student's height is 5 foot 4 inches. What is the height of the pineapple statue? Give it in terms of feet and round to the nearest hundredth. So 2 feet is 24 inches. We know that she is 5 foot 4 inches, even though it's not labeled. So that would be 64 inches. And then 8 feet is 96. Plus 9 is 105 inches. So, setting the proportion, we have 64 over 24 equals h over 105. Again, you could set this up a bunch of different ways, but the main thing is that you're multiplying 24 times h. 64 times 105 is 6,720. So when you divide by 24, you get that h equals 280. Again, this is in inches. So then you divide by 12 to get your feet, which gives you 23.33 repeating. So since they said nearest hundredth, I'm going to say it's 23.33 feet. Okay, and again, if they don't tell you to put the nearest hundredth, then you're going to put it as feet and inches, but if it does say hundredth, then you can just leave it as a decimal. So we have Jonathan, who is 3 feet from a lamppost that is 12 feet high. The lamppost and its shadow form the legs of a right triangle. Jonathan is 6 feet tall and is standing parallel to the lamppost. The ends of Jonathan's and the lamppost shadows intersect. How long is Jonathan's shadow? And round to the nearest hundredth if needed. So, when you see this, try and fill in the picture based on the information. So, we know that John is 3 feet from the lamppost. And we know that the lamppost is 12 feet high. Okay? And because the lamppost and its shadow form the legs of the right triangle, I know the lamppost is this vertical line that I labeled as 12 feet, and that the shadow is this horizontal line because those are the legs. So since he's 3 feet from the lamppost, I know that this is 3 feet because Jonathan is this other parallel line. And we know that Jonathan is 6 feet tall. And we want to know how long is this little bit right here. Okay, so to do that, we're going to set up a proportion from our big side or big triangle to our little triangle. So remember, the big triangle is this right here. Boop, boop. And then our little triangle is right in here. Okay, right there. So setting the proportion, looking at the big one, we'd have 12 over 3 plus x. Again, we need the full side of that big triangle. And that equals 6 over just x. So when you cross multiply, you get 12x equals 6 times 3 plus x. So then that would be 18 plus 6x. And then when you subtract 6x, you get 6x equals 18. And then if you divide by 6, you get that x equals 3. And remember, that is Jonathan's shadow, is what x represents. So that means that Jonathan's shadow is 3 feet long. And we do not have to round or do anything fancy with that. Okay? So, finding the ratios of similar figures. Remember, the similarity ratio and the perimeter ratio will be the exact same thing, but the area ratio is your similarity ratio squared. So, looking at this, we know that the ratio of the perimeter is 2/5. Even though they don't ask for it, the similarity ratio would also be 2/5. But since we want the ratio of the areas, you're going to square it. So 2 over 5 squared equals 4 over 25. Okay. Then number 20, the similarity ratio is 9 over 4. What is the ratio of their perimeters? Again, similarity ratio and perimeter ratio are the exact same thing. So that would be 9 over 4. Number 21, the ratio of their perimeter is 27x cubed over 81. What is their similarity ratio? These would be the same thing. Personally, I noticed that 27 and 81 have 9 in common, so I would simplify the fraction a little bit. So 27 divided by 9 is 3, and 81 divided by 9 is 9. Oh, look at that. I can simplify it even more. So then we'd have x cubed over 3. Okay. Again, the ratio and similarity, perimeter ratio and similarity ratio are the exact same thing. But if they give it to you in a non-simplified form, go ahead and simplify it too. And sometimes it may take more than once, kind of like when I did it, because I didn't know 27 went into 81 evenly. So we have the area for 22. Ratio of the area is 4 over 9. What is the ratio of their perimeters? Since the area is the squared similarity ratio, we're going to have to take the square root. So that'd be 2 over 3. And that's literally all you have to do. Whenever you're comparing area ratio, similarity ratio, and perimeter ratio, it's either going to be the exact same answer, the squared answer, or the square root, depending on which one you're given. So last one, the ratio of the sides is xy squared over z cubed. What is the ratio of their perimeters? Ratio of the sides is the same as a similarity ratio because that's how we make similarity ratios. So since it's similarity of the perimeters, it'd be xy squared over z cubed. Okay, so now we are given that triangle RTS is similar to triangle UWV. And we need to find the area and perimeter of triangle WUV. So we are given two side lengths, which is how we come up with our ratio in the first place. So since my small triangle is the one that has the measurements, I'm going to use that. So that'd be 16 over 20, which if you can simplify them, go ahead and simplify them because it makes your life a little bit easier. So our similarity ratio is 4/5. So to do perimeter, we would have 4 over 5 equals, perimeter is 36. So we'd have equals 36 over the perimeter of my big one, which we don't know yet. So we would have 4p equals 36 times 5 is 180. And when you divide by 4, you get that perimeter is 45 feet. So then to find area, you're going to use the same ratio, except you're going to square it. So 4/5 squared equals 48 over A for area. 4/5 squared would be 16 over 25 equals 48 over A. And again, if you notice, by simplifying it initially, it made this one a little bit easier because the numbers don't get quite as big. I mean, they still get big, but not quite as big as they would if you didn't simplify. So we'd have 16A equals 1200, and when you divide by 16, you get that the area is 75 feet squared. So just remember, whenever you're setting these up, you can simplify the ratio if you want to of the sides. Your perimeter ratio is going to be the same as that ratio. Your area ratio is going to be squared. And then you're just setting a proportion like you've been doing. So, number 25. Going to be doing the same thing. Now, in this case, my big triangle is the one that has the measurements. So for some people, or for some of you, it's going to be easier if you set up your similarity ratio as the one that's given over the one that isn't given. Again, simplify if you can. So 6 over 4 would be 3 over 2. And that's my similarity ratio. So to do perimeter, we'd have 3 over 2 equals my perimeter of the big one, 21 over p. And by the way, because I did it the way I did with 3 over 2 instead of 2 over 3, I did that so that I knew on the other side I would have my given perimeter over my p. And that's just a personal preference because I find that otherwise I might make mistakes, and I'd rather avoid those if I can. So 21 times 2 is 42, and then 42 divided by 3 is 14. So the perimeter of ABC is 14 centimeters. Then to do area, you take that similarity ratio and you square it. Okay, and I used 27 over A because I went from my big side to my little. So then that would be 9 over 4. Goodness, my emails are blowing up right now. Sorry. So then we would have cross multiply 9A. 4 times 27 is 108. So when we divide by 9, you get that area is 12 centimeters squared. Okay. With 26, we got some pentagons. Doesn't matter though, we can still do the exact same thing. So our similarity ratio will be 90 over 60, which simplifies a lot and also becomes 3 over 2. So we have 3 over 2 equals 381 over p. When we cross multiply, we get 3p, and 2 times 381 is 762. And when you divide by 3, you get p equals 254 meters. And not gonna lie, when I first got 254, I was a little concerned, but then looking at that fact that the big one is 381 meters, I stopped worrying so much. So then for area, same thing, you're gonna square it. So 3 squared is 9, 2 squared is 4, and that's going to equal 1,944 over A. So we have 9A equals 7,776, and when you divide by 9, you get that A is 864 meters squared. And again, even though that number is kind of big, comparing it to the area of the other one, I'm not too concerned about my answer being wrong, because it is larger areas than we've been working with in the past. All right, so last two. A boxcar has a length of 36.25 feet and a width of 9 feet. A model boxcar is 1.25 inches wide. Find the length of the model to the nearest inch. So this is when I use my labels to my advantage. Because if I'm comparing like feet to feet, then it's fine. And if you want to compare like the big boxcar to the model boxcar, then you can also use that. So actually, let me set this up slightly different. So I'll set it up with the width is 9 feet and the width of my model is 1.25 inches. And it's going to equal my unknown length of my model. So I'm just going to put X inches because we don't know. And 36.25 feet. So if you notice, my feet are all in the denominators, my inches are all in the numerators. If you had it so all of your feet were on one side and all of your inches were on one side, that's totally fine. But just be aware that when they say 1.25 inches wide, they're referring to the width, and it's going to correspond to the 9. So cross multiplying, 36.25 times 1.25 is 45.3125, and they tell us nearest inch, so I'm just going to keep that in the back of my head. When I divide by 9, I get x equals 5.03 . So because it's nearest inch, the nearest inch I have to 5.03 is just 5 inches. Okay, so sometimes you might round down, sometimes you might round up, but the easiest way to think of it is if you think of that as money, that'd be $5.03. So are you closer to $5 or are you closer to $6? Just another way to see it. So our last one, an enlargement of a painting is 24 feet wide. The original painting is 58 centimeters wide and 73 centimeters tall. If the enlargement is similar to the original, what is the height of the enlarged painting to the nearest foot? And that is a typo. Boop, 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 boop. So because I know it's 24 feet wide, that's going to compare to the 58 centimeters tall. And so because we're looking for the height, I'm going to label it as H because we're looking for feet. And my foot was in my numerator for my other side. And we know that the picture is 73 centimeters tall. So cross multiplying, we would get 58H equals 24 times 73 is 1,752. And when you divide by 58, you get 30.20689, and it just kind of keeps going and going and going. So since they want the nearest foot, we have 30.2 feet. So if you think about it in terms of money, $30.20, you're a whole lot closer to $30 than you are 31. So my nearest foot would be 30 feet. Now that is the end of the review. If you think that perhaps I did something wrong or you want some clarifications, you can either ask me in person or leave a comment and I'll try and respond, or you can also email me. So I hope this helped you review for your test, and happy studying!